So, are you going to spend your day, week, month, year adding up the terms, or can you guess the answer? You can do it using intuition. You can use it also. You can do it using ancient Indian Ganit Sutra also. And let me tell you, this is the basis of calculus. And now University of Manchester also kind of approves, or rather they have confirmed that Leibniz and Newton, they were inspired, or they got this idea of calculus. When I completed this book, the manuscript, showed it to some of my scholarly friends or scientist friends, they said, okay, ancient Indian glory, everyone knows. But what about today? Can be applied to solving modern problems. So within 15 days, I wrote a research paper. I used ancient Indian Ganit Sutra by Pingalacharya and Kedar Bhatt to calculate probability distribution in a Colton's board. Did you know that the binary number system was developed in India? That algebra was also developed in ancient India? That Bodhayan Sulva Sutra predates Pythagoras' theorem. What is popularly called the Pascal's triangle is predated by Pingala's Meru Prastaar by at least 1800 years.
From the land of Ramanujan comes My Mathematical Musings by Chandrahas M. Halai, a book that will make you fall in love with math. This mathematical thriller delivers a roller coaster ride of recreational mathematics, full of surprising results, counterintuitive outcomes, powerful proofs, perplexing puzzles, challenging problems, and amazing applications. Explore self-describing numbers, figure-eight numbers, birthday problem, handshake problem, Josephus problem, secret message matrices, and von Neumann's fly dilemma. From Mendel's bees, linking statistics to genetics to paper-sized standards, there is something for everyone. Discover the joy of mathematics.
Chandrahas M. Halai, a passionate mathematician from India's rich heritage of Aryabhatta, Brahmagupta, Bhaskara, and Ramanujan, works as a consultant in computer-aided engineering, optimization, computer science, and operations research. He authors research papers, articles, and books across mathematics, physics, engineering, and related fields, while pursuing nature photography and painting in his leisure time.
Hello, everyone. I think I have also studied normal social sciences, etc. And this interview of me with Chandrahas sir, a mathematician, is mine also first foray into the world of mathematics. Your book starts with why Indian mathematics. We have heard loud claims about ki India gave decimal system, India gave calculus, India gave this, that. I'm definitely a very proud Indian. Definitely that is there. But beyond that, what? I really am not able to appreciate my ancient Indian mathematics because my lens is today's mathematics. I can't see it like that. So despite I have a lot of pride in what India gave, but I'm not able to understand it. I'm not able to appreciate it. So first tell me, what is the India's most important achievement in the field of mathematics? And somebody who understands today's maths, for that person, what lies in it to understand ancient mathematics? Yeah, so I'll answer your question. Rather, what is the most fundamental and profound contribution of India to the world of mathematics? Generally, everyone knows the answer. Rather, the most common answer is we gave the decimal number system, we gave zero. And we have another misconception. Aryabhatta gave zero. Yeah. Well, no mathematician or a student of history of mathematics will tell you that Aryabhatta gave zero because there was zero present centuries before Aryabhatta. So all this misconception is kind of spread by Leibniz, left liberal journalist, and the Urdu word
who rarely do any research or referencing. Not every movie is Dhurandhar that they will go into detailing or research. So the biggest contribution, according to me, other mathematicians, they will have their own vision or opinion. According to me, according to my research or my work, is the main or the most profound and fundamental concept of mathematics. Decimal number system, that is base 10 number system, is one of the instances of place value number system. So if you look at human evolution, we have 10 digits, 10 fingers. So we counted, the caveman counted on fingers. So the base was 10. If we would evolved like alien, like, and let's say there's a very remote planet where alien life emerges or evolves, and if they have 8 fingers, then they will have a base 8 or octal number system. But ultimately, they will, like, you had the Europeans had the Roman numerals, then you had the Sumerians, Babylonians, Mayans, Incas. So Mayans had base 60, but of course, it was not the place value number system. You can say very refined, very accurate number system was the place value number system, decimal number system that India developed. And they developed the numerals. And because of place value number system, you had the symbol 0, the bindi or the circle. So it was because of the place value number system that the concept of 0 was born, so that you have a placeholder. Then negative numbers. India gave negative numbers. Till the 17th century, European mathematicians did not accept the existence of negative numbers. For them, it was very abstract. How can I have negative money? How can I have a negative distance? How can there be something physical which is negative? This abstract, entertaining the abstract thought, representing quantities as symbols or place value number system, was a refined, sophisticated thought of the Indian rishis or the Indian public in general. So our society or civilization was a scientific temperamental society. If you look at our heritage monuments, like the Kailash temple at Ellora, the Elephanta at Garapuri, or the Elephanta caves at Mumbai, they are so accurate. You look at Mohenjodaro, Dholavira, Lothal, which had a synthetic man-made port, locks and gates. So they were technically very evolved society. And if you want to be a technically evolved society, that cannot be done without mastering mathematics or measures and counting. Yeah.
So like you said, the place value system,
Hmm.
it's the overarching place value system. The decimal system is a part of it. And because of the place value system only, we can talk to computers, because
Yeah.
computers
So
operate in
let me
zeros
make
and
that
ones.
second point. Yeah.
Yes.
Yeah, you can complete the question.
Sir, my question is, most of us are intimidated with mathematics. So my direct question is, now I read mathematics in certain way, the way NCRT and CBSE has prescribed the syllabus to me. How will it make my life easier?
Okay. So first thing, that at a very, very young age, like when you are like in your first standard, grade 1, you are made to learn by rote multiplication tables. That puts off a young, curious kid to hate that subject or become bored. What am I doing here? Why am I learning by rote? And of course, now the kids are fortunate, they are lucky. Otherwise, we used to get that hit by a cane. And I have received the maximum in my batch. Because till 8th standard, I never used to remember the multiplication tables. Because I didn't need to learn by rote the multiplication tables. Because I knew what was multiplication. And same multiplication can be done in 6 to 7 different ways. And that is described in the first chapter of Bhaskaracharya's Leelavati. And Bhaskaracharya's Leelavati is a fun-filled book. It is not boring like today's text. It is fun-filled. So you are dealing with groups of monkeys, a swarm of bees. You are you are actually dealing with Karna Vadhai, means slaying of Karna by Arjun. So Arjun has a quiver full of arrows. 2/3 destroys kind of Karna's chariot. So all this is mentioned in my book Meru Prastaar. So it is made engaging, it is made interesting and easy to understand. And the entire book Leelavati is in verse. It is set to poetic meters. It's a poetry. Bhaskaracharya was a poet, astronomer, a mathematician. He wrote the book Leelavati to teach mathematics to his daughter Leelavati. So a parent who loves his daughter will always write a book which his child will enjoy. And of course, Bhaskaracharya is my favorite author, mathematician, inspiration. And I jokingly always say, why I'm good at mathematics? Because my grandmother's name was Leelavati. And I learned mathematics from her. So maybe my grandmother was incarnation of that Bhaskaracharya's Leelavati. And I was fortunate to learn mathematics from Leelavati.
Actually, the impression that I got while reading Meru Prastaar is that when we deal with mathematics in today's world, we are dealing with mathematics in silos. But when I'm dealing with the way mathematics is shown in this book, it's like everything is mixed together. There's storytelling, there is patterns, there is so many analogies. So I get confused. Is it really mathematics or all the world together in one field? Yeah.
So, like coming back to the first chapter, Yatha Shikha Mayuranam, then next thing is kind of the first starting of the book Ganitasarasangraha by Mahaviracharya. Now, Mahaviracharya was a Digambar Jain monk. 1200 years back, he wrote a book, Ganitasarasangraha. Actually, Bhaskaracharya was kind of inspired to write Leelavati by reading Ganitsarsangraha by Mahaviracharya. He has said that he was inspired by Ganitsarsangraha. So in Ganitsarsangraha, Mahaviracharya says that where is mathematics used or applied? In economics, in trade, commerce, cooking, chemistry, architect, romance. A Jain Digambar monk is not averse to talking about love and romance. And he says that it is time calculation, motion of the planets, calendars, counting seasons. Like we had accurate calendar. And he says that there is nothing in this three worlds, animate or inanimate, living or non-living, which is bereft of mathematics. You will find mathematics everywhere. So this was the vision 1200 years ago that ancient Indians had. And Ganitsarsangraha is also like Leelavati, fun-filled examples like groups of monkeys, then traders, partnership, interest.
Actually, this is a very, the fundamental way, the difference in the gaze between Western lens and the Indian lens, that they see everything in silos and we see that there is a connection, an interconnectedness among everything in life. So if you can demonstrate me with some practical examples, how Indian mathematics is used and make life easy for me, make it easy for me to solve that problem.
Shall I demonstrate something?
Yes.
Let me ask you a question.
Okay.
Let's check your...
Don't put me in a spot.
Very simple thing. I will demonstrate it using my hand key.
Okay.
Okay. What is ha?
You have to help me.
Yeah, ha. Plus 1 over 4, plus 1 over 8, plus 1 over 16, plus 1 over 32, plus 1 over 64. Go on adding hundreds and thousands and millions of such terms. You see, 1 over 2 and 1 over 4, or 1 over 4 and 1 over 8, or 1 over 64 and 1 over 128. They have a common ratio. They are always divided by 2 or halved. The consecutive terms are halved. So now if you add up infinite such terms, will it converge to some finite value? Or it will just go on increasing or go to infinity?
You are adding infinite quantities.
Such terms, yeah. Terms. I'm adding up such terms. So are you going to spend your day, week, month, year adding up the terms, or can you guess the answer? You can do it using intuition. You can use it also. You can do it using ancient Indian Ganit Sutra also. And let me tell you, This is the basis of calculus.
Okay.
And now University of Manchester also kind of approves, or rather they have confirmed that Leibniz and Newton, they were inspired, or they got this idea of calculus from,
You're saying that will it converge to something
or
different?
will it get closer and closer to some finite value, some fixed number?
I guess so, because as the values are getting lesser and lesser,
But
so it
then,
will.
yeah, but there has to be some rule. We won't go into the rule. The rule is explained in the book.
So do you have some interesting anecdotes, etc., from your book which you can tell us about?
Yeah. Now, uh, there is one interesting thing. Does anyone do Sandhya Vandanam? During Sandhya Vandanam, you recite Chaturvimshati Keshavanam. The 24 names of Vishnu. Why only 24? Why not 26 or 23 or 21? Now, Sri Hari Vishnu, Lord Narayan, he has got 4 hands. In 4 hands, you have the 4 ayudh, Shankha, Padma, Gada, and Chakra. So, 4 objects, they can be arranged in 24 different ways. 4 objects. Suppose if I have 4 people are sitting here, 4 chairs, they can be arranged in 24 ways. That is 4 factorial way. 4 times 3 times 2 times 1. So, 4 ayudh can be arranged in 24 ways. And for every arrangement, unique arrangement, you have a unique name. We have an order of the 24 names. So, for every arrangement, you have a unique name. And there are temples like Chenakesho temple at Hoyshala temple, Chenakesho, near Bangalore. On the exterior walls, you have all the 24 forms. And then there is one Balaji temple in Fanaswadi, Girgam, Mumbai. On its exterior wall, also they have kind of put up all the 24 forms. Means the Swarup is the same, but the only thing that is different is the arrangement of the 4 ayudh. So now, at Rani Ki Vav, new 100 rupee note has the picture of Queen's Stepwell or the Rani Ki Vav at Patan, Gujarat. So it has got hundreds of sculptures, beautiful sculptures. We'll forget Michelangelo and Europe. Beautiful, amazing sculptures. So at Rani Ki Vav, there are some 15 or 16 forms of Narayan. There are 31 sculptures, some are repeated. But there are 15 or 16 forms of Vishnu, where this arrangement, the Swarup is the same. Only thing that is different is the arrangement. So this was a problem given in Bhaskaracharya's Leelavati. So he relates his problems or concepts with what you observe in your day-to-day life. And everyone must be cooking, or everyone must be eating different flavors of ice creams. So if I have got 6 flavors and I have a choice, right, I can have 3 of them, I can have 4 of them, I can have 2 of them. How many different combinations can I have? So this is permutations and combination, or mathematics of choice and arrangement. So this is one example in Leelavati. There are 6 ras: sweet, sour, astringent, and so on. So if you have got 6 ras, how many combinations can I have? Or if I have 6 flavors or 6 ras, how many different chutney or sauces I can make? This is a problem in Bhaskaracharya's Leelavati, demonstrating that mathematics is applied to cooking. To make something interesting, there are problems in Ganitasarasangraha and Leelavati, and also in my book. Means all these problems are mentioned in my book with photographs and sketches. So that lover gave his fiancée some gems. So with some gems, she made a kind of, what you say, ladies are क्या बनाते हो? हाँ, then necklace, बाजूबंद, earring, kamarband, whatnot. Now, which lady would not like to have such a lover? यार इतना सारा gemstones देता है. Okay, 1/3 went there, 1/6 went there. So how many gems were there? These are the kind of problems in Ganitsarsangraha and Leelavati, 900 years back, when The Europeans didn't knew even how to count.
So for those who are intimidated by mathematics or those who don't like mathematics, so what is the intellectual hook or entry point for those people?
My teachers, my seniors, they have also written books, but those are meant for people like me. I'm like a bridge between them and you.
And for those people who are interested to who are getting their kids homeschooled, so if they study this mathematics, will they be able to sustain competition exams?
Yeah. Let me come back to it. Now, have you heard? Everyone must have heard the name of Manjul Bhargav.
Yes.
Who is who is Manjul Bhargav? He's an Indian American professor at Princeton who won the Fields Medal. Now, there is no Nobel Prize for mathematics. So, mathematics has a field medal. It's a very prestigious thing. Now, Manjul Bhargav was interviewed. He said, where did you get the inspiration for your profound fundamental work that got you this Fields Medal? He says that his grandfather was a kind of a Pandit, Mahapandit of Sanskrit. And he had learnt Indian mathematics. From that Indian mathematics, he got the inspiration for his research, or profound research, or a path-breaking research in mathematics. So he got that inspiration from Indian mathematics.
And my final question is, this cover, most of us recognize this as Pascal triangle, and you name it as Meru Prastaar. So are you kind of reversing the gaze from Western to Indian?
Yeah. Well, that's the differences between an original and a photocopy. From the horse's mouth, or rather from the primary source, to a one who was like kind of just lifted the idea. I would not say that Pascal didn't do original work, but he might have got an idea from ancient Indian work. So we know that Jesuit priests used to take our scriptures to their European lands, and their scholars used to wait to study Indian scriptures. And we also know that the Badshah of Baghdad in the 7th century had invited Sanskrit scholars, Indian mathematicians, astronomers to Baghdad, and they had kind of translated Indian works to Arabic, and from them they got the idea of calendar. Julian calendar, Gregorian calendar, we all know they were not accurate. They learned. All those things are mentioned in Meru Prastaar, most of them. Of course, this is more, you can say this is like, okay, initiation. Like once you read Meru Prastaar, a lot of things will become clear to you.
So I would just like to say that whatever conclusion that we can go about is like the ancient Indian mathematics should not be kept in a museum. It's a living tradition through which we can find practical utility. Right?
So yeah, let me just conclude that when I completed this book, the manuscript, I showed it to some of my scholarly friends or scientist friends. They said, okay, ancient Indian glory, everyone knows. But what about today? Can we apply it to solving modern problems? So within 15 days, I wrote a research paper. I used ancient Indian Ganit Sutra by Pingalacharya and Kedar Bhatt to calculate probability distribution in a Galton's board. And that paper was appended as the last chapter of this book.
Right.
So it is very much, you can have one look at a problem and you can recite ancient Indian Ganit Sutra to solve problems. Like also what is popularly known as Vedic mathematics. You look at some computational problem and you can use a Ganit Sutra.
Right.
Note.
Thank you so much, sir.
Thank you.
Indian Mathematics School.
Great.
In our visit, we found there were Leelavati and Kundarka Shastra and Trigonometry and everything. What we thought, I mean, what we saw was that most of the mathematics there was applied mathematics. Unlike what we study during college or school, it is theorem or formulas and then this explained. There is very little applied mathematics. So is that true? Is that observation correct that Indian mathematics
very
is
much.
mostly about applications of math?
Very much. Very much. If you look at our ancient Indian mathematicians, they were not just pure mathematicians. They were astronomer mathematicians. Or Pingalacharya. Pingalacharya wrote a book on Chanda, poetic meters. From poetic meters, he developed the mathematics of binary number system, the foundation of today's digital technology. Not only binary number system, he also developed algorithms to enlist combinatorial sequence generation, quick exponential calculation, radix conversion. If I go on, that will be very technical stuff. But I'm just giving you an idea. He was not just a prosodist. He wrote on mathematics also. And of course, Charak Samveta, which is like 3,200-year-old scripture, was the, you can say, the methodical study of combinatorics began in Charak Samveta. Acharya Chanak, Rishi Chanak also wrote the two chapters in Charak Samveta are on combinatorics. Combinations of dosh and combination of ras. So it was practical. It was not just developed for to show off like, okay, I got a degree, I wrote some research paper. It was to solve some practical problem. And earliest mathematics that was developed in India, algebra, was developed to design Vedi, Havan, Vedi.
बहुत बहुत धन्यवाद चंद्रहास सर